Hello again, and this is PMCD Maths teaching bearings. And my name is Paul McDonough, and I'm going to go through how this is usually at GCSE, this particular introduction to bearings, but this is what I would use as an introduction to bearings, and then the progress that I would use that I would use from there onwards. Okay, this is useful for new teachers, experienced teachers. You might find something useful in here as well, or ideas that you can perhaps improve on what you're already doing. Okay, so rationale. Okay, I feel pretty strongly about this actually, because if you teach it, even from a textbook, sometimes they'll use maps. Often it's just, very, very boring, plain diagrams. And if students have got no experience of bearings at all, this just seems absolutely pointless. So role-playing, really. Role-playing exercise here to help them experience what it's like to draw bearings and perhaps know about the consequences of being inaccurate with that. Sequence of teaching. Okay, as you can see there, it's not hierarchical in that way, but I would expect, drawing measuring angles accurately. In fact, we're going to need that a little bit later on with the problem solving and translation, the column vectors, that link between translation, the column vectors that we use when we do translation, and actually how we can express bearings as vectors as well. And that's more of an extension task, but it gives us scope to go somewhere with that. So what do we start with? I normally start with just checking that they can draw angles accurately. So something very, very easily there to start off with. And I will check those with my protractor as well once they've done each one. So that's a little bit of running around the class doing that as well as I possibly can. And once I'm happy with that, we get on to the first task. So we try and get them all to do the same, thinking about what's going on here. So, using some of these aircraft that my previous career when I was used to be in the Air Force, so it's quite easy for me to find reasons for using bearings accurately anyway. So what we've got here, the waypoint being the position basically. So this is what they're saying. From waypoint 1 would be bearing 0, 0, 10 miles. How can this mission be plotted on a map? Okay, so we don't go straight into this, but I'm just giving an example. This is the set of instructions you might be given as a pilot. How would you plot that? How would you know you'd end up there with that? So next thing I talk about is how the pilot might see this in instruments. Okay, so the instruments here, the horizontal situation indicator, and the numbers around the outside. We talk about those being numbers on a compass, not the compass with a point that we use to draw circles. Good time again to reinforce that that's not the same thing. And the 3 being 30 degrees, 6 60 degrees, or E being east, which is 0 9 0 degrees, and so on. But it sort of captures the imagination a little bit that this is how this would be used. That the aircraft are flying in directions in relation to this sort of instrument. And the tasks. Okay, they've got 3 flight paths they're going to draw on the map. So I found these 3, and then you can check the answers afterwards here. Again, it's up to you. You can use this or you can change it. It's up to you. I will. I think I've got these. I can attach these in the notes as a file. But you can change these to what you want, and hopefully they're accurate. But if they're not, I'm sure they're easy to fix here. You'll notice as well that each one I'm putting as a 3-digit bearing. This is one of the things that very important to emphasise. We also discuss why 3-digit bearing. Well, if the pilot's expecting a 3-digit bearing, they're expecting 3 numbers, there will not be a complication. So if you said, okay, it's 30 degrees, say you gave 2 bearings and the actual bearing was 130, and for some reason that one didn't come through, the pilot would know that there's a problem, so it may ask you to repeat it. So we have to have that convention to make sure that communication is clear. So or even 030. Is it 30? Is it 130? Is it 230? Having that 3-digit bearing is important. And the definition, obviously, that it's measured from north clockwise. Again, we have a lot of discussions about that. Why? Why clockwise? Well, it's a convention, isn't it? Why do we drive on the left-hand side of the road in the UK? But if all pilots were using their own methods, some going clockwise, some anti-clockwise, flight paths, for air traffic controllers, it's going to be difficult to see which direction. They won't be able to monitor where aircraft are flying. We could have a very chaotic sky and perhaps some disasters as well. So it's like a convention. So very important to get that over, because you'll find that students will, even when we go back to when we draw in some of these bearings, they might be tempted to rotate in a anti-clockwise direction. So, little practice task, and this is the map of Hertfordshire, where my school is. But I'd encourage you to use whatever works for you. Now, it's taken me a while to get this to work for me, and this isn't the printout that I use. I've got another document I use to print out. I can attach that for those people who live in Hertfordshire if you want to use that. And I use that scale. And I'm not saying it's perfectly accurate, but it's good enough for us to be able to do what we're doing with this particular task here. Keywords mentioned down the bottom there. You can bring those in as and when. And what I do to get them to say, right, everybody, can you draw 030 at 10 miles? Using 7 centimetre equals 10 miles scale. So we do that, and we check that everybody can do that. Okay. At this point, we are stipulating, as we do on any bearing diagram, that north will be the top of the paper. That doesn't mean that north is the top of the paper. We can align that with a compass north, couldn't we, so that it lines up. But these things, all these little details, I think, help to establish some sort of credibility for bearings to them. Because obviously, if you've got students facing different directions, north is the top of the paper, that doesn't make sense, does it, to them? Why can your north be any direction you like? If we actually line this up to north, and again, if you can bring in a compass, if you've got a compass, maybe even worth purchasing one for the department, that you can actually show them this, all the better. And there's probably online versions of them anyway. Okay, so once I'm happy with that, then we get into a task here, and I've got 3 different tasks here. They can go through, they work their way through. So these are ones that I've worked out, and these are ones I've got solutions to as well. So they have to plot the path of the aircraft using the scale as well. So a bit of scale comes in here as well. So, and actually I've failed to mention that, I think, in the prior requisite teaching. So scale drawing is important for them to understand that. But you can sort of do that a bit by the back door here. I think they probably make sense of it if you discussed it in this lesson. So maybe it doesn't, maybe you can actually get that in this lesson as well. And finally, what they do, they'll end up with the final position, and they have to work out the bearing and distance from the final position back to King's Langley, which is where the school is. But again, you can change this to your school. You can make it now. Again, this takes a bit of effort to personalise this, but what you actually have at the end then is a resource you can use year on year if you've taken your time with it. And much more motivating, I think, than just simply downloading a worksheet and working through bearing problems. Much more motivating for them. So there's 3 levels, if you like, and I've got a little extension task there. You probably won't use this with all classes. Find the column vector displacement vector from the King's Langley to the final position. They can do that by measuring a vertical and horizontal distance and then changing it into a column vector. It's a nice way to link it, even if you just show it to the class as a plenary, just saying, look, do you remember this? It's nice to link these things up. Seems like maths all works, it all jigsaws together. Okay, so that's pretty much the activity that I've got there. And then what I've said, you can hang on to these maps. They are a good foundation then for when you teach vectors. This is the result here, what I've got here. So I've got I've taken time to do this. It's taken me time, but it's something I've used again and again now. And I actually enjoy going to teach this lesson. I really do enjoy it, because I'm not feeling like I'm just pulling out a load of protractors and a worksheet, let's do some bearings. Very, very dry. I think it can be otherwise. This is then, I said, can be used for vectors then. So what I've got now is a little network. You're going to see, if you watch my vectors video, you will see that I use this again as a way of getting them into understanding what a vector can can be used for, in particular in those case, displacement vectors. Okay, so that's the drawing and a bit of measuring of bearings. Okay, they'd have to measure the distance back and the angle back as well. And, you know, that might need a bit of follow-up in a subsequent lesson. I mean, it probably will do, because, you know, measuring reflex bearings, I suppose if you call them, can cause problems. They often try and measure the acute angle instead, which means they end up going anti-clockwise. But anyway, this is the start. This is the start we've got here. Okay, so yeah, I've just noticed that scale is 5 centimeters, 10 miles. I think it is 7 centimeters equals 10 miles. I'll have to change that. That looks like a mistake there. Okay, so what else can we do with bearings once you've done that? Well, there's little problems here of measuring bearings. And I've got one here. This is from just an image from, I think this was from a 10 ticks sheet I had. If you ever come across 10 ticks, but there's lots of resources here. Again, I've used this as a separate lesson. Find the bearings of Dragon Rock to Skull Island, and from Ship Z to Skull Island. So we do a little check together first. This is my start activity, and I'll go around and check that they've got the right answers and they're measuring things right there. So that'd be a limited time activity, and then I would set the task for them. And they've got ship A, B, C, and D, bearing from Dragon Rock, distance from Dragon Rock, bearing from Skull Island, distance from Skull Island. So that's a good measuring activity that you can use. If you don't have 10 ticks, you haven't subscribed to 10 ticks, then I'm sure that you can. I'm sure that you know there are alternatives out there. What else have we got? Things I've used here. These are just some ideas, other resources you can use. There's, you know, something like using maps to solve problems. There was back in the, I think this was the Jubilee, the Golden Jubilee. There was a load of activities put out on this, and this little card sort you can cut up. And what they've got to do is try and work out where these beacons are by that were lit around the UK. So you need a map of the UK to do that, and you locate the beacons by using this information. So that's another example. Final sort of thing I wanted to talk about quickly was the from to type thing. And this is more of an exam preparation, but I think it's a good way of consolidating their understanding of bearings. So this does look abstract, okay? And, you know, I don't particularly like this sort of approach, but sometimes this is how it appears in exams. And as much as we say we're not preparing students for, you know, just preparing exams, they have to be familiar with it. So I focus on the word from and to here, okay? And by using, obviously, the bearing of y to x, we're looking at this, this angle here, this reflex angle. Let's get this pen working again. Okay, so we're looking at y to x, we want that angle there. And this is where you bring in the angle facts information. There's two ways, obviously, of doing this. You can extend this line, then understanding that by corresponding angles, we've got 72 and 180 for the straight line. Or if you extend the north line, I mean, it's your preference, really. You can see that 072 fits there, plus 180 now on this line. So a little bit of practice for that is good. And then you can throw in, I'd like to throw in then an actual exam question once we've done a bit of that. So something like this. And this was a past exam question. Now, you notice here, they may be tempted to draw it accurately. They only need to sketch it, really. It's not about measuring on this one. I think it says work out is the key question there. So yeah, I think that's the full range of stuff that I would cover if I was going through bearings. And, you know, that might take, you know, five lessons perhaps overall. Depends on the ability of the class and how quick you go through that. And you can go off in different directions depending on how well they're doing. I mean, going into expressing them as vectors is an obvious extension. Okay, I hope you find that useful. As I said, I'll attach any resources in the notes so that you can get hold of those and adapt them for yourselves. And I can't say strongly enough. It really is worth putting a bit of time in. I know it takes time to get this these resources developed, but they're there for you then, and then you have patches of, these are little lessons that you've developed, and you look forward to teaching them, because you know it's something interesting, that the students are going to enjoy it too. Okay, that's enough for me, I think, for this time. I hope you found something useful there, and I'll see you next time.